this question is kind of tricky to explain. It's saying for the same signal emitted by a radio antenna, so with this same signal, what that really means is that the P, the power, is going to be constant. It's the same signal as the same radio antenna. You can assume that P is not going to change throughout this, nor will, say, for example, down here, P divided by 4 pi, that will also not change between observer A and observer B. What will change is the distance, r, and the intensity, felt, I. So here's our original equation, and it says that observer A measures its intensity to be 6 times the intensity measured by observer B. So what I think I want to do is I want to move these over to the other side and put all the stuff that's going to stay constant over here and r squared times I over here. So in that case, what we can say is that if it's the same power divided by 4 pi, then these two expressions are going to be true for both the observer A and observer B. Here you might have a very strong I here, but a very small r here, and that could equal a very weak I and a very high r. They both, at the end of the day, when you multiply these two together and multiply these two together, they should equal each other, even if they're not equal each other at the very beginning. So high I, low I, high r, low r. Anyway, if you rearrange these yet again, you get I over A and I over B. The intensity felt by the observer A divided by the intensity felt by observer B. Why did I do that? It's because we know that this is 16. IA is over IB is going to be 16. So if this were something like 32 and this would be 2, they divide the 2 and you get 16. Or if this were 160 and this were 10, you could divide the 2 and get 16. Here, you've got RA squared and RB squared. And you can, so moving everything else to the other side, you get this. And actually, because it's 16, you can take the square root of both sides. You get 4 is equal to RA over RB. And if you take the reciprocal of both sides, you get RB over RA. Why would I want to do that? Well, it's because I want to know what fraction of the distance observer B from the radio over A. So B over A would be 1/4, and that's your answer. It happens to be 1 over the square root of 16, which is here. If you do that in the wrong direction, if you forget to do the square root, it's just 1 over 16, that might be this trap answer. Or if you forget to, if you do it in the wrong direction, instead of taking this square root, if you square it, then you'd get this trap answer here. Another way to think about it, this is an alternate method, is just to remove P, take this formula and remove P and 4 pi, and just say that I is equal to 1 over r squared. Similar to the previous question in number 22, if you moved r squared over here and I over here, you get r squared is equal to 1 over I. And then you could take the square root of both sides, and you get that r is equal to 1 over square root of I. Now, if the intensity gets multiplied or increased by a factor of 16, like if this is going to go up times 16 from A to B, then the radius is going to go up by 1 over square root of 16, which is 4. It's just a way of saying, like, comparing A to B. If you would double this, it would do one thing. If you multiplied it by 16, then that will make this radius go up by a factor of 1/4 as well. And there it is. Another way to do this problem would be to guess and check numbers. You could, if you wanted to get really, complicated with your calculator, you could choose a value of P and calculate out what this would be. And maybe that would be an easier way of doing it for some people. You could figure out what you could guess a value for P, you could guess a value for R, and then you could calculate I and calculate what the new I would be and the new R would be for the new observer. And if you feel like that's what you'd want to see, then you can ask your tutor, and your tutor will show you how to do that. And if that's me, then that'd be awesome. I'd love to show you.